Okay, today I'd like to talk about the three different types of electricity, two of which Nikola Tesla discovered himself and figured out how to work with them. The first type of electricity is called DC, or direct current, meaning that the current only flows one way down the wire, and it's always a constant. Just like a straight line, it's always in a constant, going the same way. The second type of electricity is called AC, or alternating current, meaning that the current goes one way and then reverses and jogs back the other way. So the current is always flipping polarities at 60 cycles per second. The third type of electricity is called impulse, or transient currents, meaning that the current actually spikes and then shears off. So it goes from zero to top, back down. This is called scalar, and it has no frequency. The frequency on scalar is imaginary, and it's measured in decibels per second. It's like sound, like a sound decibel, okay? Now, Nikola Tesla discovered the alternating current and the apparatus in his AC motor on how to extract energy using his device. Nikola Tesla also discovered the impulse or the transient currents, or the scalar. And this was the basis for his death ray. When it got to this point, after those three types of electricity had been known, basically all electrical engineering and testing was halted. This is in the early 1900s, because two people named Marconi and Alexanderson went around all of Tesla's patents and took everything that Tesla had already figured out to that point and were able to produce extreme phenomenon with their system using scalar, basically. So let's talk about how the currents work, okay? Like I said, in DC is always constant. It's always running one way down the line. It never changes. Whereas in AC runs one way down the line and reverses polarity and comes back and switches at a rate of 60 cycles per second in the United States. Okay. Now, the third type of electricity, which is not known by most people, is called transient currents or impulse currents. What they are, they're wave spikes in the waveform. Meaning, if you look at them on an oscilloscope, a normal AC wave is just like a bell-shaped curve. Whereas in an impulse current, the waveform, but it's not really a waveform, goes up at a complete shear angle and comes back down at a shear angle. So they're just spikes in the waveform. It's an exponential form, okay? What it does, according to Eric Dollar, he says that the energy starts in an oscillation. Okay, it starts running just like a normal sine wave. Okay, the sine wave is compounded with a dampening wave, and this produces an oscillating current. Okay, so these currents no longer have frequency in the conventional sense. DC has no frequency either because it's just a constant, whereas AC is a constant frequency, like in RPM, in cycles per second, right? It's always changing. Okay, whereas an impulse is an imaginary frequency. An impulse is actually measured in decibels per second, just like sound, like you turn up the decibels. Okay, so those are the three different types of electricity, two of which Nikola Tesla discovered and figured out the devices on how to use them. The most interesting, in my opinion, is all the phenomenon that comes from using the scalar or the impulse or transient currents, because what they were able to do, meaning Marconi and Alexanderson, they set up an antenna system and they could actually manifest or demanifest material out of the ether. And they were using a system that has no time delay, meaning that it's instant. And there's no power loss from one end to the other end, meaning that if you start one end and you have 1,000 volts at your destination anywhere in space, there will be 1,000 volts at the other end. There's no loss in current, and it's instantaneous. It's faster than light because you're using the dielectric side of the equation, not the magnetic. Okay. And this is where the whole deal with counter space starts. You have space and you have counter space. There's only two dimensions you have to work with: space and counter space. If it's not in space, it's in counter space. But electricity always exists in space and in counter space simultaneously. Always. So it's always simultaneously in these two different dimensions. So Tesla actually figured out with his system of the scalar, he figured out how to get out of space and into another dimension, meaning counter space. And Alexanderson Marconi took their system and figured out how to get not only out of space, but how to circumvent space and go around it and make an object appear in a distant location. So they figured out basically how to get outside of time. But time really doesn't even exist, but it does when you're measuring things, or when you're counting spins and rotation. That's when time actually really matters. Okay, so those are the three different types of electricity, and Nikola Tesla's the brilliant genius that came up with the two of them. And with his AC motor, proved his professor and everybody else in the world wrong, that told him that you couldn't make AC happen without using a commutator. And Tesla figured out how to do just that. And that's what's running all of our AC motors today, with the help of the Steinmetz patents. So, thanks for watching this video. Have a good one.